Good morning, chemistry students. It's me, Mr. Cheney, with another brilliant tutorial. This one is for Energy Skate Park Part 2. Previously, we did the Energy Skate Park Basics, so you want to make sure you get that done first. Right here is the YouTube video tutorial to get through that. This one is with the 5 slides. Just as a review, you are going into the Basics Park and you are answering these questions and putting these charts over on the kinetic, potential, and total energy as you do the simulations for 2 different tracks, the U track, the L track, and then this last slide right here, they've given you this kind of wavy W track, and you're kind of calculating and guessing what the kinetic and potential energy is for point A, B, C, D, and E. So that's the first one, and now let's get into the second one. This might be a part 1 of 2 video. We'll see how long this goes. So Energy Skate Park number 2, which is the second simulation in the PhET labs. And we're going to try something a little different. Found this app called Pocket Lab that kind of lets us work within its own document, so we don't have to switch back and forth. So we're just giving it a try. You're clicking the orange Students Login button. There is no class code because you're going to log straight in with your Google credentials, the @wolfcobras.com, and you're going to come in here and you're going to see an assignment called Investigating Kinetic Energy. We're going to click on that, and yesterday as a class we went through the learning goals. So basically we're calculating kinetic energy, and the formula for that is half times mass times speed squared, or velocity. Velocity is the same thing. We watched this really cool NASA video about how gravity's effects in space and that sort of thing, and then we went over what kinetic energy is. So it's just kind of a review of what we've talked about for the past week or so. All moving objects have kinetic energy, which can be written as E subscript K. The KE of an object, the kinetic energy of an object, depends on its mass, its speed. So once again, the formula is kinetic energy equals half mv squared, which is mass times speed squared. V stands for velocity. And the answer that we get is going to be in the energy unit of joules, Joules, kinetic energy in joules. So the example that we went through was right here. So we have a car that is 1,000 kilograms and it's traveling at 10 meters per second. So how do we calculate the joules of energy? So our formula again, half mv squared. Our mass is 1,000 kilograms. Our velocity v is 10 meters squared. So here's how you set up the formula. Half times 1,000 times 10 meters squared is going to be 50,000. So let's show that on the calculator here. So if you were to take, we're going to go with the one in the parentheses first, so PEMDAS, if you remember that from math. 10 squared is 10 times 10, or you can use the squared button. So we've got 100. We're going to go 100 times 1,000. And we've got 100,000, and then we're going to divide that by 2 or multiply it by 0.5, which is half. So I'm going to multiply it by 0.5 to keep it consistent with our formula, which gives us our 50,000. That agrees with our 50,000 here. So you are clicking into your response here and you are typing the answer, 50,000 joules. Okay, so I believe that's, well no, we got further than that. So then we got in here, and this is the actual Energy Skate Park. We're going into the measure section, and you can actually do the simulation right in here instead of having to go to Clever and go into the PhET labs, which is why we're trying this. So these 3 dots, you can do a full screen, and you can go back like this to get back to our Pocket Lab. So what they're telling us to do is this. We are setting up our experiment. We want an L track, not the U track, the L track. We're pulling the first red dot up to 8 meters. Before that, we're putting our grid on so we can see where 8 meters is. And we're going to use the energy meter to take a reading of the final speed when the height is 0. So it's the first pink dot after the 3rd red mark. So there's the red mark. We go to the pink dot where it says 0, not 0.03, but 0. We're going to get that speed and we're going to do some calculations. So let's set up our track, and this is how we do it. We go to the L track right here, put on our grid, and we're going to put this up to 8, and we're going to do our first trial. So let me show you the table we'll be filling in. We're going to be doing height 8, 7, 6, 5, 4, all the way to 1. So all those different heights we're going to do. The gravitational potential energy, that's what GPE stands for. At the top, it goes there. And our mass. Our mass is going to be the same for all trials. We're going to keep it at 60 kilograms. So that's what it's at right now. And so we can fill in that part of the chart all the way down. So I'll do that. Mass is going to be 60 for each one of these. Okay, so now I'm going to get my skater up to the 8 meter height. So we'll go back up. And I'm going to go with dog instead of and we're going to put dog like so. And we're going to let it go, and we are going to pause after the dog leaves the screen. And now we have our pink dots that we can actually measure. So there's 2 measurements we're going to do. The first measurement is, like they said, the first pink dot after the red, where you have height 0. That's going to be your maximum speed, which is 12.48 meters per second. It might be different for you, and you want to go with your number, because when you make these tracks, there's a little variance in like how the curve happens based on where you place it on this grid. So make sure you're using your number for speed. So 12.48. So I'm going to go back, and in my chart I'm going to put 12.48 here, and I need to get what the GPE was at the top, so I can measure that as well. So I'll go back to the simulation, and I'm going to take my measuring tool to the top dot up here, and my potential GPE was this, 4655.4. So go back. 4655.4, and then now I've got to calculate the kinetic energy. So once again, let's get that calculator up, and we're going to clear this out. And so my meters per second was 12.48, so I need to square that, 12.48 squared, and then I'm going to multiply by the 60 grams, and that's going to give me this, and then I'm going to divide by 2 or multiply by 0.5, which is half. So I'm going to multiply by 0.5, and my kinetic energy is 4672.51. We're going to go 2 decimal points. So 4672.51, and that's it. That's for height 1. So now we're just going to repeat for each height. So to set up your next height, like number 7, what we're going to do is, don't do this orange button. What you want is the restart skater. Otherwise you're going to restart and have to build your track again. So I'm going to bring this guy down to 7, so the line number 7 right there, and I'm going to let him go and press pause. So I have my pink dots, and I'm going to measure where it says 0 height. See how that says 0.03? That's still a slight height, so I'm going to go to the next one. So my speed for this one is 11.70. So we'll go back, and we'll fill that in, and we'll calculate again. Our next measurement, we got to go get that GPE, so we'll go do that as well. So our next measurement is going to be at the top dot right there, and our GPE potential energy is 4084.2, so we're going to put that in the chart. 4084.2. And then I'll calculate this out. So we'll get our calculator up, and we are going 11.70 squared times our 60 grams, and we are going to multiply it by 0.5, and we are going to get 4106.7. And And so now we're going to do all of those, and part 2 of this video will be placing our data down here so we can get a plotted chart. So our goal for this first part is to get this full table with all our runs completed out, and then we'll go to part 2, and I will be helping you out during class. See you back in class.